Hello, I'm Sri from CBTU. CBTU presents a course on Amazon Web Services AWS, section Amazon EMR benefits. There are many benefits in using Amazon EMR, like cost savings, AWS integration, deployment, and let us see all these. Amazon EMR pricing depends on the instance type and number of EC2 instances that you deploy and the region in which you launch your cluster. And you can reduce the cost by purchasing reserved instances or spot instances. Spot instances can offer significant savings, as low as 1/10 of on-demand pricing in some cases. Amazon EMR integrates with other AWS services to provide capabilities and functionality related to networking, storage, security, and so on for your cluster. The AWS services are Amazon EC2 instances, Amazon EC2 for the instances that comprise the nodes in the cluster, Amazon Virtual Private Cloud, Amazon VPC, to configure the virtual network in which you launch your instances, Amazon S3 to store input and output data, Amazon CloudWatch to monitor cluster performance and configure alarms, AWS Identity and Access Management IAM to configure permissions, AWS CloudTrail to audit requests made to the service, AWS Data Pipeline to schedule and start your clusters, and many other services are well integrated with Amazon EMR. EMR cluster consists of EC2 instances, which perform the work that you submit to your cluster. When you launch your cluster, Amazon EMR configures the instances with applications that you choose, such as Apache Hadoop or Spark, etc. Choose the instance size and type that best suits the processing needs for your cluster, like batch processing, low latency queries, streaming data, or large database. Amazon EMR offers variety of ways to configure software on your cluster. You can install Amazon EMR release with chosen set of applications that includes versatile frameworks such as Hadoop and applications such as Hive, Pig, or Spark. Amazon EMR uses Amazon Linux, so you can install the software on your cluster manually. Amazon EMR provides flexibility to scale your cluster up or down as your computing needs change. You can resize your cluster to add instances for peak workloads and remove instances to control costs when peak workloads subside. Amazon EMR provides the flexibility to use several file systems for your input, output, and intermediate data for processing. Amazon EMR monitors nodes in your cluster and automatically terminates and replaces an instance in case of failure. Amazon EMR provides configuration options that control how your cluster is terminated, automatically or manually. Transient cluster. If you configure your cluster to be automatically terminated, it is terminated after all the steps are complete. Long-running clusters. When you configure a cluster to continue running after processing is complete, so that you can choose to terminate manually when you no longer need it. Amazon EMR leverages other AWS services such as IAM, VPC, and features such as Amazon EC2 key pairs to help secure your clusters and data. IAM is Identity and Access Management. Amazon EMR integrates with IAM to manage permissions. You can define permissions using IAM policies, which you attach to IAM user or IAM groups. We're going to cover these other AWS services in other sessions. Security groups. Amazon EMR uses security groups to control inbound and outbound traffic to your EC2 instances. When you launch your cluster, Amazon EMR uses a security group for your master instance and security group to be shared by your core task instances. Amazon EMR configures the security group rules to ensure communication among the instances in the cluster. Amazon EMR supports optional Amazon S3 server-side and client-side encryption with EMRFS to help protect the data that you store in Amazon S3. Amazon EMR supports launching clusters in Virtual Private Cloud in Amazon VPC. A VPC is an isolated virtual network in AWS that provides the ability to control advanced aspects of network configuration and access. AWS CloudTrail. Amazon EMR integrates with CloudTrail to log information about requests made by or on behalf of your AWS account. You can track who is accessing cluster, the IP address from which they made the request, and other information. Amazon EC2 key pairs. You can monitor and interact with your cluster by forming a secure connection between your remote computer and the master node. You use Secure Shell SSH for this connection. You can use Amazon EMR management interfaces and log files to troubleshoot cluster issues such as failures or errors. Amazon EMR provides the ability to archive log files in Amazon S3, so you can store log files and troubleshoot issues even after your cluster terminates. Amazon EMR also provides an optional debugging tool in Amazon EMR console to browse the log files based on steps, jobs, and tasks. Amazon EMR integrates with CloudWatch to track performance metrics for the cluster and the jobs within the cluster. You can configure alarms based on a variety of metrics such as the cluster is idle or the percentage of storage used. There are several ways you can interact with Amazon EMR. Management Console, a graphical user interface GUI that you can use to launch and manage clusters. You can view the details of existing clusters, debug and terminate clusters. Using the console is the easiest way to get started with Amazon EMR. Amazon CLI, Command Line Interface, a client application you run on your local machine to connect to Amazon EMR and create and manage clusters. AWS CLI contains a feature-rich set of commands specific to Amazon EMR. With this, you can write scripts to automate the process of launching and managing clusters. SDKs provide functions that call Amazon EMR to create and manage clusters. You can write applications to automate the process of creating and managing clusters. The SDKs available are Go, Java, .NET, C# and VB.NET, Node.js, PHP, Python, and Ruby. Web Server API, a low-level interface that you can use to call the web service directly using JSON. Using the API is the best option to create custom SDK that calls Amazon EMR. Thanks for watching.